All right, so today's lesson is called Measures of Variation. Measures of variation just means how things vary. So we're going to be able to find the mean absolute deviation, which I'm going to abbreviate, and for our data set. So we're just going to find the average and how things differ from the average. All right, so on slide 2, it says a restaurant asks the staff to record the number of people who ordered the special each day. The table shows the number of specials ordered that day. To find the mean of the data set, remember we add them all up, and I've already done this. So we added all these numbers up, we get 168. Divided by 8 would give us that the average at this restaurant, or number of specials, is 28 over that time period. Again, I just added all these numbers up. Complete the table by finding the absolute value of the difference between the mean and each data set, each value in the set. So that just is saying how far is this number from this number, and this one from this one. So 26 is 2 away from 28. 25 is 3 away. 30 is 2 away. 32 is 4 away, so that's a little above average. 27 is 1 away, and 28 would be 0 away. Find the average of these values for the difference between the mean and the table. So we're going to add all these up. 5, 6, 7, 8, 12, plus 0 is 12, divided by, again, the 8. So 12 divided by 8 is going to give us our mean absolute deviation. 12 divided by 8, not 1.8, is 1.5. Why did I do 8? 6. 12 divided by 6, there's 6 data points. I don't know where I got 8 from. 12 divided by 6 is 2. There we go. So the mean absolute value deviation is 2. That just tells me that on average it's 28, but we could go up to 30 or down to 26, and that's really going to be the range at which those specials, the number of specials, fall. Okay, so we've got a vocab word here. Mean absolute deviation. I abbreviate that MAD. M-A-D. You've used measures of center to describe the middle of a set of data, median and mean, and you've used range to describe the spread or variation of a set of data. Another way to describe the variation of a set of data is to use its mean absolute deviation. The mean absolute deviation of a set of data is the average distance between each data value and the mean. So it's the mean of the mean. That's what I call it, the mean of the mean. So we're going to, step 1, find the mean. Step 2, find the absolute value, which is, that's just how far away from the mean each number is. Then find the average of those differences. So then find the mean again. And then step 4 is going to be to write a sentence to describe the mean absolute deviation. So we're going to go through a few of those. Okay, so on slide 4, it says a table shows the heights of the first 8 people standing in the line to ride a roller coaster. Find the mean absolute deviation, so the average height of the set of data described what that mean absolute deviation represents. So find the mean. So if I already added all these up, when I added all those up, I got 448 divided by 8 data sets or people, and we got that the average height is 56 inches. There's our mean. Find the absolute value of the difference, so how far each table value is from the mean. So 52 is 4 away, 48 is 8 away, 60 is 4 away, 55 is 1 away, 59 is 3 away, 54 is 2 away, 58 is 2 away, and 62 is 6 away. Step 3, find the average of these values. So we're going to add these all up and divide by 8. So we're finding the mean of the mean. So that's 30 over 8. Simplifying, we get 3.75 inches. So that just means that the average height is 56, but the data could be anywhere from 56 minus 3.75 all the way up to 56 plus 3.75. That would be the majority of the people. So here's our sentence, and you can copy this sentence exactly if I don't already give it to you. The average distance, each person's height in this case, is away from the mean, is our mean absolute deviation, 3.75 inches. Okay, so here we're going to go do that again on slide 4, 5. The number of points that Samantha scored in 5 basketball games was that. Find the mean absolute deviation of the set of data, so the mean of the mean. Describe what the mean absolute deviation represents. So, step 1, add them all up. When we add all those together, we're going to get 52. Divided by her 5 games, we're going to get, on average, she scores 10.4 points. Step 2 is to find how far each one of those numbers is away from 10.4. So 8 is 2.4 away. 14 is 3.6 away. 10 is 0.4 away. 7 is 3.4. And 13 is 2.6. Step 3 was to find the mean of those. So add those all up. And we get that it's 12.4, and divided by her 5 games, it's going to give us an average of 2.48. So on her good days, she would score, 12, almost 13 points, or we can subtract that back. So step 4, the sentence, if I don't give it to you, we'll write it out. This is a carbon copy, so take this sentence. Average distance each game, each of her game points, each of her game points were from the mean was 2.48 points. So there's our sentence. Pause me if you need to. Another vocab word, the standard deviation of a set of data is a calculated value that shows how the data deviates from the mean of the data. In a given set of data, most of the values fall within one standard deviation of the mean. So they're close, that means. So if the mean of a set of data is 21 and the standard deviation is 3.5, then most of the data values fall between 21 minus 3.5 or 21 plus 3.5. So it shows you a nice visual of that. One standard deviation is just a fancy term. Don't worry too much about it. Just your closest points. So our step 1 is going to be find the mean still. Step 2, find the range of values that are within the standard deviation. So just add and subtract the deviation from the mean, and write a sentence to describe the standard deviation. Again, I will help you with the sentences. A couple of those where we do the standard deviation. So step 1 is to find the mean. So these all add up to 99. There are 12 of them. So the mean would be 99 divided by 12, which is 8.25%, I suppose, because it's a quiz score, or points. I'm not really sure about this label, because it doesn't really say, it just says quiz scores. And it says the quiz scores, class A is about a 1.2 for the standard deviation. So to find the range of the values, we just take our mean, and we add the standard deviation, and we also take our mean and we subtract the standard deviation. So if we add it, we get 9.45, and the other one will be 7.05. So those are our values. It just means that the quiz, the majority score between 7 and 9.5. So here's our sentence. Quiz scores that are between our low value, and I would label it if I knew, and 9.45 something, are within one standard deviation of the mean. Just practicing using that word. Okay, so it's not too bad. Find the mean. Everything we've done today, find the mean. If they give you a standard deviation, find the range. If not, if they're asking for the mean absolute deviation, you have to find the mean absolute deviation. So one more where we're using standard deviation. Here's a table from exercise 1. The standard deviation of the amount of caffeine is about 14 milligrams. Describe the data values that are within one standard deviation of the mean. So that means we have to add all these up. When we add them all up, we get 302. And there are 10 of these. So the average, in this case, would be 30.2 milligrams of caffeine. So step 1 was find the mean. Step 2 is going to be add or subtract the standard deviation. So 30.2 plus our 14 will give us our high amount of caffeine, so 44.2 milligrams, and 30.2 minus 14 milligrams is 16.2 milligrams. So here is our most likely range of caffeine values. Step 3, the sentence. So if we just look at slide 7, we can kind of copy that, but we just make it appropriate for our label. So caffeine amounts between 16.2 milligrams all the way through 44.2 milligrams are within 1 standard deviation of the mean. So that basically you just need to change a few words, but that's your sentences every time. Beavers' teeth never stop growing. Have a great day.